Welcome again, and in this lecture we are going to continue the remaining part of ambient aerosol sampling, and we are going to now discuss that what are kind of samplers that we have. We have already discussed in the previous lecture that what are the sampling considerations. For example, what you are going to collect, what is the purpose or objective, where are you going to collect. This means you have to define the representative sampling locations, and when you define the sampling location, your sampling location must be representative. This becomes very important. So most of the time, this, if you are a researcher, this question will be asked, that how your sample is actually representative of urban location. For example, I am doing the sampling at Varanasi, so how we are going to do this one. And in CPCB guidelines, if you are collecting samples in a city which has more than 15 million people, so what you have to decide, you have to have actually kind of at least 5 sampling locations. So 3 should be within the city and 1 outside, kind of upwind, and 1 in the downwind. Or you can also say that so 5 locations has to be there, and when you get the 5 locations, obviously if you just see that whether these 5 locations have concentration different or not, they will obviously will have the concentration difference, because they are not going to have same concentration. So concentration will never be same. So you have to remember that one, and that's why sometimes your source apportionment studies are when you are doing the chemical composition, they could be actually biased. So obtaining a representative sample is very difficult, or sampling location, and sometimes it becomes for the logistic point of view, it is also becomes important that okay, some places you have some better logistics, so you prefer to collect the samples there, because at that location you have access to everything. For example, if you are putting the samplers there, one common thing could be there, that there could be birds that will be spitting there. There could be actually outside monkeys and other things, so they can disturb your samplers and other things. So you have to just remember that where you are going to do sampling, you have to ensure, and then of course because these samplers will need electricity, so just cannot go and put sampler anywhere actually. So even if it is representative, but you have to logistically look at it. There are not, I cannot recommend one simple good things or simple idea or simple thing that where you should be doing the sampling, but when you have identify the way it should be done, you identify 3, 4, 5 locations, and then you see that okay, these are the good points, these are the plus points if I do sampling here, this is the negative points, and then based on that actually you can decide that okay, this is the location that I should be choosing this one. So this becomes very important. So we say that what we are going to measure, where we want to measure, why we want to measure, we have already discussed about the objective of the sampling, and when we want to measure, about the timing. So this is already there, we have already discussed this one. Okay. So coming back to again objective, because in generally the objectives becomes very important. So whenever you do, especially if you are a researcher, then this question becomes very pertinent and it becomes very important to you, that what you are looking for or what we are looking for. So this is actually one of the very biggest problem that I have seen in many of the students, especially the PhD or master's students. They usually come and they straight away, sir, I want to do dissertation with you, or I want to do PhD under your guidance, or and when you say that okay, let's sit and discuss and frame our objectives and then decide the sampling locations, I will tell you that most of the time these students, they will not be able to frame the objectives very properly, and this is where the guide is needed. Actually guide support is needed, but even the guide cannot help actually in that one, because until the students is very clear about the idea, and guide can help actually. So for example, when we talk to my students, I see, okay, these are the 5 objectives that you have listed, okay, and based on the objectives I see the importance, whether this objective is really important or whether that objective, sometimes they put this, for example, monitoring of air pollutants, for example, say monitoring of PM10 concentration. So this cannot be your objective actually, this is not at all objective. Why? Because anyway you are going to do whether optical properties study, or you are going to do chemistry, or you are going to simply the aerosol chemical composition measurements. So this sampling anyway you have to do, without sampling you cannot do, so that in principle cannot be your objective. Sampling, collection and monitoring cannot be an objective. This is as forward as it, it should be. So what is the objective? Objective you have to decide, okay, that I want to study the chemical properties of aerosols or chemical composition of aerosols at Varanasi, okay, and then the again thing, now the representative location, site, everything will come here. So you have to ensure that one. And so this, if you want to do the chemical composition, now how, the next question is that how time resolved you want to do. You want to do 8 hours, or you want to do everyday sampling, or you want to do hourly measurements. So in generally when we do filter sampling, filters based analysis or filter based kind of research, offline that we call it actually, I don't know if it is there or not, yeah. So when we do offline measurements, okay, so this chemical composition part when we are doing, mostly we do by offline measurements, and then when we are doing offline measurements, your time could be varying between say more than 8 hours to up to 24 hours. More than 8 hours or say less, about 8 hours, generally it is not, less than 8 hours is not preferred. So 8 hours, say for example 8 hours to 10 hours, and when you are doing the sampling, it is also not very possible that every time you switch off and switch on at exactly the same time, so that 8 hours is maintained. So sometimes it may be 8 hours 15 minutes, 8 hours 30 minutes, plus minus, half an hour could be okay, but not much that one. So, and for example, so it is in the urban area. If you are doing for the pristine environment or the high altitude sites, what will happen? Their air pollution concentration is very less. So air pollution concentration is less, and if you are collecting for shorter time, then what will happen? You will not be getting the enough samples. So if you are not getting the enough samples, your chemical composition measurements will be little bit, or you may not be able to get all the concentration in that itself. So this becomes very important. So you have to decide whether 8 hours, 10 hours or 12 hours or 24 hours. For example, we also did lots of study, and one of the idea that was very highly cited, we just did day and night sampling, and we wanted to see the differences in the chemical composition and then optical properties, and that idea was actually well taken. Lots of paper came after that one, and that is very highly cited papers of ours. So this becomes, so this is where your little very small things counts actually in research. So you should be very optimistic, you should be very doing these things, okay. Then for example, if you want to more on total number concentrations, for example, I talked about mass concentration. If you want to measure number concentration, your instrumentation will be entirely different. If you want to measure the optical properties or optical coefficients, or you want to measure some physical properties like density, refractive index, water content, then these things actually will be different. So your idea and your all the sampling depends on what kind of things are the objective. Based on the objective, you will decide your sampling, okay. Then whether you want to do online or offline measurements. So analyze the samples. When we say analyze the samples online, we generally actually monitor directly there. So you directly get the concentration and you directly get all the things immediately. because the way the system is made. And now I am happy to tell that there are instrumentation techniques that are there in the aerosol itself, that they can hourly, they can not only hourly, they can hourly give you, for example, carbonaceous species, ECOC in the air. Ion chromatography you can do, ions if you want to measure, you can get at every 30 minutes. If you want to use aerosol mass spectrometer, even further fine resolution data you can get. So lots of instruments have come, and this has given a lots of understanding about the processes that is happening in the atmosphere, or the chemistry that is happening in the atmosphere. So we can do that one. And then if you are if you are doing offline measurements, what you have to do, you have to collect the filter samples and bring the filter samples in the lab, and you have to do the chemical analysis in the lab itself. You cannot do that one, okay? So you have to do chemical analysis in the lab. This is very time consuming and tedious job. Then integral, there are now methods, integral measurements and size resolved measurements. So at a place actually you can integrate couple of measurements. It could be actually like your optical properties or physical properties. You can either combine chemical properties. So if you want to doing actually kind of this one, integral measurements, this is very important, this is very advanced, and this needs a huge funding. So you have to have lots of instrumentation in this one. So I will be focusing now more on filter sampling, or this is offline. So when I say this, so this filter sampling means I am now talking about mostly on the offline methods. I am not going to discuss much of the things. And the way it is done, it's done by the filtration. That the idea is about the filtration. I discussed in the previous lecture, if you just remember, that how this filtration techniques is actually working, okay? And there are usually two types of samplers. One is called high volume and other one is called low volume, okay? So samplers, they are decided in that way. Generally high volume means, as the name suggests, they has high Q flow rate, okay? And they low volume means you are collecting less volume, okay? So low volume, low flow rate, the Q is less here, and generally they are say up to 16.6 liter per minute or so. So they are actually in the low volume, and then here high volume, they are actually like 1 meter cube per minute. So this kind of things are there actually. So for example, if you are doing the sampling and this because this high volume sampler becomes very important, especially for the pristine environment and high altitude sites. Low volume samplers, they have their own idea, because when you are doing of course there are problems. I will discuss that in later, but just to give you, because let's not forget that when you are doing low volume sampler, this means samples are collected very, so you are not collecting very fast, you are collecting like very small. So the particles that is already deposited on the filter surface, what will happen? They will not be impacted much by the particles that is getting deposited in the next time. But when you are doing the high volume sampler, one of the problem is that you do very good chemical composition measurements, but for example, if you want to do physical properties, so for example, if you are doing kind of scanning electron microscope, and then which gives the kind of surface features of our morphological features of the aerosols. So if you are using very high volume sampler, that is actually avoided, because when you are doing this kind of things, particles may get, and then the particles, interaction between the particles can lead to change in the morphological features itself. So that is actually avoided. Then so here actually like generally we have high volume samplers like TSP, you can use TSP, or we also have PM10. Now we are having like PM2 2.5, they are actually mostly preferred for the low volume sampler. Then have you dichotomous samplers, PM 2.5 and PM 2.5 to PM 10, both coarse mode you can collect. Then cyclone impactors, okay, if you want to further classify different particles, PM1, PM 2.5 and PM 10 different sizes. So as the size you have to use the cyclone, we will discuss, because that cyclone will guide the particle path actually. Then you can also have personal samplers, like you can just put in the pockets. That is also there, but that is not advisable much in the research. It's just kind of some occupational studies and personal exposure studies, you can do that one. Then inertial impaction, you can have kind of cascade impactor, or you can have a moody multi-orifice uniform deposit impactor. So here the idea is mostly dependent on the inertia of the particles that is there, and that can be used for the collection of the samples. This becomes very important. And of course another very thing is actually done, like by gravimetrical settling itself. So particles are deposited directly because of their own gravity, and in this case what you are going to get, dry deposition. Okay, so this becomes very important when you are doing flux kind of flux measurements, how much flux of the particular nutrients, for example, is deposited. So you know that what is the velocity, okay, velocity with which is, for example, it is meter per second, and then you know the concentration in microgram per cubic meter. Okay, so from there you can directly calculate that, okay, if the settling velocity is this much, I think I had given example of this one or not, but so just remember that, okay, you can calculate the settling, if you know the settling velocity, you can calculate the flux. And not only that, usually in a way, to be very honest with you, or here, that PM1, PM10 and PM 2.5, we do calculate their deposition flux, but that is actually when we take depositional velocity or VD, it is computational one. So we compute that actually how much, because the point is that PM 2.5 and PM1, they will not be depositing actually by their natural deposition or gravimetrical settling. So if they are not depositing, then their deposition flux calculation has no meaning in principle. And then if you want to do for electron microscopy, I give very important things here, like or then elemental composition you want to do. So by for example say XRF you want to do, okay, yeah, then such kind of things are actually low volume samplers are preferred. So there are advantage and disadvantage of high volume and low volume samplers. High volume samplers are usually very good if you are collecting the samples as remote location where the air pollution concentration is less. So the concentration, and if you have to get adequate samples, what you do, you have to collect the samples, either you increase the time, so collect for 2-3 days for example, with the low volume sampler, that is not advisable. And then you increase the flow rate itself, but then if you increase the flow rates, you can do chemical composition, that's okay, but if you want to looking for the morphological features and then some of the optical properties, that might be actually disturbed, so that we have to take care. Oh yeah, so how do we do the collection and analysis of measurements? So most common collection media is filter. So wherever all these samplers, whatever you see in the right side, they usually are done on the filters, and filters are subsequently analyzed either gravimetrically, we will discuss, or chemical or biological methods for whatever things that you are looking. If gravimetrical, you will get the mass, and all the chemical species you do chemical composition measurements, even some of the things you can do biological. Inertial separating device classify particles based on their inertial properties, okay, and inertial properties means every object has inertia, and when it is moving, it try to moving in that same direction, it doesn't want to get distracted with that one, so that actually you can do, okay, inertial properties such as cyclones and impactors, okay, and these can be used to classify sizes, different size and collection of the particle size distribution as well here. Okay, so if I coming to the sampling unit, what are the complete system that will be looking like? So as I said, you have actually like here you have particles, that is particle laden air is there in this one. So you have kind of air parcel which contains lots of particles. Now if you are just putting kind of a bucket here and you are collecting some samples here, you get something. So this is actually like dry deposition it becomes, okay, because you are just putting within by deposition itself, and as I said, this becomes for the particles whose diameter is very large, for larger particles, okay, which comes directly under the influence of gravity. Otherwise what you do, these air somehow, this air, there are actually, you see here 2 openings here, and not only 2, there are many actually. So this will be completely like circular, this will be all opened, it is circular. So from there air can come actually. Now once the air is there, what is the other things? Now you have to decide here, once the air, you have a device that okay, opening is there and then air can come from there, then what you have to do, you have to do size selective inlets. So you have to decide what size of particles you are going to collect, okay, and then if you are going to do this one, for example say PM10, PM2.5 or TSP, so you have to decide accordingly, you have to design your sampling system. Then there is sometimes people use denuder. This is important because denuders are very important. They usually the air contains sort of water vapors and other humid pollutants, so that can be removed by denuder. And then here you have filters, okay, so the filters here you will know, you need to have a filter holder on which you can keep the filters, and then on which the particle filters, on which the media on which the particles will be collected, and then you can have a backup filters. So this is actually like different kind of things. On the filter you have one filter here, so particles are collected, and then whatever the left are there, you can just put it a backup filter. Backup filters are usually used to see that whether we are able to collect the samples effectively in the previous one or not, or what is the concentration that is left actually. So you can also collect from this one, and as I said that because it will not be directly coming with this one, so you need to get some velocity or some flow rate actually you need to know. Air will not directly come, okay, until it's very windy, and but that windy can come actually and then come inside, but it will not go in the system, it will not be deposited. So what you have to do, you have to put here actually a kind of pump. This is very important, and this pump is needed because this will, when the filters when the particles are deposited on these filters, then what will happen, this pump is needed actually. Otherwise if the pump is not there, then air particles, the particles that is there in the air will not be deposited. And then once the particles are deposited on this one, what will happen, imagine a situation that this filter particles will be choked, it is not, it will not allow the particles again, or the velocity or the flow rate will be reduced. So you need to have a mass flow controller, okay, and then you need to meter. So accordingly, depending on the pressure difference, this mass flow controller, what the idea of the mass flow, or the job of the mass flow controller is to keep on collecting so that the same flow rate is used, because we will see that in the calculation when you see, you have to calculate PM, okay, and as you know that this is actually microgram per cubic meter. So this is the actually total mass that is actually deposited. This total mass you can get by gravimetrically. How you do? You actually take an initial weight of the filter, blank weight, and with the filters you just subtract final minus initial, and this is actually your delta W you can say. So this you know that how much of particle mass is there. And the next thing actually that it is because we are discussing here that how much air actually we have sucked, how much actually the volume. So this is the volume of the air that is actually sampled, how much volume that you have to sample, and this is done actually because you know Q, which is for example say meter cube per minute, and then multiply by time, say unit is minutes here. So this will give you actually the volume. Now the point is here that if your sampler's flow rate is changing, then what will happen? Because you cannot keep on monitoring all the things actually. So usually we take average flow rate, okay, and this is changing, and this flow rate should not change. For this purpose we use mass flow controller, okay, and once you have the mass flow controller, then we use a kind of average flow rate, average Q, and then average this, for example say 6 hours or 8 hours, and that's why one of the things that is there in the CPCB that you every time, every hour, 1 hour you measure what is the Q1, and then 2 hour you measure the Q2 dot dot, and then for example you are doing the sampling for 12 hours, then you measure that Q12, and then you take average Q, okay, and this average Q or Q bar, if I just put it, so this Q is actually like nothing but is Q bar, so Q bar into T. So this once you have, then you can calculate total volume of the air that is sampled, and then because we have removed all the gases, only particles we have collected, I know that how much particulate matter was there in that particular system. So I could be able to calculate particulate matter concentration in PM microgram per cubic meter. So this is how it is done. So these are the 5 very important components: size selective inlet, denuder, filters, and flow controller and pump. This is actually a kind of schematic. If you see this one, I was trying to tell you. So this is like particulate matter head that looks like this, and yeah, in this one you have, this is actually the filter holder or the filters that is there actually, and then kind of filter substrate that is actually put in the cascade of the filter sampler, and then air is coming from this side, air is can come from this side. So this is actually coming from all the 4 directions, so 360 degree air is coming. Then once the air passes through this filter, all the particles are deposited here, and then only the air with no particulate matter comes in, so you have air out here, okay. So this is how you actually do. So this kind of samplers are actually used for mass concentration and PM composition. So you can do PM 10, PM 2.5, okay, these are very common, and then you can actually do the chemical composition measurements. The principle is inertial impaction and interception of the particles, and then as I said that you can just calculate that 60 meter cube per hour means 1 meter cube per minute, okay, to 600, so it will be like 1.66 meter cube per minute. This is very high. Generally in such PM10 filters we usually use very larger filters, because if you are using very small filters and your flow rate is very high, because you are using for example 1 to 1.6 meter cube per minute, if you are using a larger smaller filter size, what will happen? Your filter will be getting choked very early, so the maintaining the flow rate will be very difficult, and then the characteristics may be changed. So usually we do kind of 24-hour sampling as I discussed, so there is no point in discussing again here. This is actually thermo Anderson sampler that is shown. You see here, these are actually kind of nozzles, and these nozzles are very important. They have very importance in collecting the aerosol samplers. So when the air passes through these nozzles, what will happen? the particles with the larger particles will be deposited or impact. So we use for example, if you want to collect PM10, but this air contains more than 10 also, more than 10 micron. So what we'll do, this more than 10 micron, before all the air coming here, there will be actually kind of grease medium and substrate will be there, and this will actually what it will do, it will actually, because of the high particle size, larger particle size, so it has more mass and more inertia, and when it impacts with the grease surface, it will be just attached with that one. Okay, this I will discuss in the next lecture. So thank you again for your patience, and I think you are getting some idea about the aerosol sampling systems and then what types of samplers that we use. So in the coming few lectures we will discuss more about the aerosol filters, aerosol sampling systems, and then use of the filters and other things. So thank you very much.